Just try to wrap your head around that for a second. I'm not talking about some chilly ice age with glaciers at the poles. I mean a world where the equator, the hottest, most tropical part of our planet, was completely buried under a massive sheet of ice.
It really does sound like something out of a sci-fi movie, doesn't it? But what if I told you this wasn't fiction at all? Okay, let's get into this, because we're about to open up one of the greatest and coldest unsolved cases in the history of planet Earth.
So, our story kicks off in an era that is so completely alien, it's almost impossible to picture. We're going to peel back the layers of time to a point when our world went into a deep freeze so profound, it's unlike anything that's happened before or since.
To really get a feel for this, look at these numbers. The average temperature of the entire planet was below -50 Celsius. That is just brutal. The ice covering the oceans was up to a kilometer thick in places. And this wasn't just some polar phenomenon. We're talking about massive glaciers grinding over the land where New York City is today, where Tokyo stands. Even tropical places like Hawaii, a true global winter.
And here is the paradox, the twist that makes this whole story so fascinating. You'd think, okay, a world of death, right? Game over for life on Earth. But what the science is telling us is something completely counterintuitive. This extreme deep freeze was actually a necessary step. It was a kind of crucible that set the stage for the explosion of complex animal life, including, way down the line, us.
So, I know what you're thinking. How in the world could we possibly know any of this happened hundreds of millions of years ago? Well, the planet keeps a diary, and it's written in stone. So let's put on our detective hats and see how scientists read those clues.
The official name for this time is the Cryogenian period, which lasted from about 720 to 635 million years ago. And the name is just perfect. It's from the Greek krios, meaning ice, and genesis, meaning birth. So literally the birth of ice. This tells you right away it wasn't just an ice age, it was the ice age that defined this whole chunk of Earth's history.
And this is the million-dollar question, right? Having ice at the poles, sure, that happens. But to prove that the ice stretched all the way to the tropics, you need some kind of undeniable, in-your-face evidence. You need a geological smoking gun.
And here it is. This is our smoking gun. It's a type of rock called diamictite. You can think of a glacier as this giant slow-motion bulldozer. It just scrapes up everything in its path. Boulders, pebbles, sand, mud, and mashes it all together. When the glacier finally melts, it drops that whole jumbled mess, which eventually hardens into this very specific type of rock. It is the unique, telltale fingerprint that says, a glacier was here. So here's the bombshell. Using technology to figure out where the continents used to be, geologists started finding diamictites from the Cryogenian period in rocks that were located smack dab on the equator 700 million years ago. Finding evidence of glaciers in the ancient tropics is, well, it's like finding a penguin fossil in the Sahara Desert. It completely breaks the rules and meant scientists needed a wild new theory to explain it. Now that we've seen the proof, let's zoom in on the main event itself. Because it wasn't just one long freeze. There were two major ones during the Cryogenian. And we're going to focus on the first one because it was the longest and by far the most intense.
It's known as the Sturtian glaciation. It kicked off about 717 million years ago. And when it did, it plunged our planet into a winter that was just epic in scale.
I just want you to stare at that number for a moment. 57 million years. Not a tough winter that lasts a few months. Not an ice age that lasts a few thousand years. 57 million years. Our brains aren't even really built to comprehend a timescale that vast. So let's try to put this into perspective. Think about the time that's passed since the dinosaurs went extinct. That's about 66 million years ago. That entire span of time includes the rise of all mammals, the evolution of monkeys and apes, and the entire story of human history. The Sturgeon glaciation, just one ice age, lasted for nearly that entire stretch of time, an almost unimaginable winter.
So what was it like living on this planet? Well, under that ice, the oceans would have been this bizarre alien place. With the surface sealed tight, there were no waves, no wind on the water, just utter silence. And in the deep, cut off from the air, the water became anoxic. It ran out of oxygen. That caused a strange chemical reaction where iron, which usually rusts away, just started building up and up in the water, waiting for something to change.
Now you can probably guess that an idea this extreme wasn't just accepted by the scientific community overnight. Oh no. The journey of this idea from a wild hypothesis to what we now understand is a great story about how science really works, through fierce debate, skepticism, and eventually overwhelming evidence.
So here's the quick history. Back in 1992, a Caltech geologist named Joe Kirschvink is the one who coined the catchy name Snowball Earth. But for years, it was kind of a fringe idea. The real turning point was in 1998 when Paul Hoffman and Daniel Schrag at Harvard published this incredible paper. They presented evidence that this massive freeze was followed by an equally massive, super-fast global warming event. That paper really lit a fire under the scientific community, and slowly but surely, the wild idea of a snowball Earth started to become the best explanation we had.
The debate didn't stop there, though. It just got more specific. The big question then became, okay, but just how frozen was it? Was it a solid ball of ice, or was it a little mushier?
And this led to two main camps. On one side, you have the hard snowball theory, which says the planet was almost totally locked in ice, with maybe just a few little pockets of life surviving near undersea volcanoes. On the other side is the slushball theory, which suggests that maybe there was a belt of open ocean, or at least slushy water left around the equator, which would have made it a bit easier for life to hang on.
So, where are we today? Well, scientists are still arguing about the fine details, because that's what scientists do. But the overwhelming weight of the evidence, from the rocks to the climate models, now points towards something very, very close to a hard snowball. It seems Earth really did go through the most extreme version of this scenario. So, we've looked at the evidence for the freeze, we've explored just how intense it was, but if you can believe it, the end of a 57-million-year winter is actually even more dramatic than the beginning. The Great Thaw is where the biggest secrets are hidden.
Because here's the thing, understanding the ice is really just setting the stage. The truly mind-blowing questions are all about what happened after. The deep freeze was just the first act of the play.
So just think about all the doors we've opened. How could life possibly survive under a kilometer of ice for millions of years? What kind of force is powerful enough to break that kind of global freeze and cause a catastrophic super greenhouse event? And the absolute biggest question of all, how did this planetary cataclysm directly set the stage for the Cambrian explosion, the sudden arrival of animal life? Where did the first animals, like sponges, even come from?
You know, we've really just given you the highlights here. Getting the answers to those huge questions is what the full 15-chapter deep dive is all about. It goes into the nitty-gritty details of how the freeze and the thaw actually worked, and it's even got incredible extras like a super detailed timeline and a whole encyclopedia of the organisms that somehow survived. It's where you'll find all the answers.
This trip back to Snowball Earth isn't just a cool geology lesson, it's really the story of our planet's resilience and the almost unbelievable chain of events that had to happen for us to even be here today. Your journey into this lost world has really just begun. The rest of the story is waiting.
All right, today we are taking a trip back in time, way back, to one of the most extreme, almost unbelievable periods in Earth's history, the Cryogenian. And we're going to do it with a 10-question quiz to see what you really know about the time our world was a giant snowball.
So, are you ready to put on your geological detective hat? Think you can piece together the clues that ancient rocks have left behind? Well, your mission is simple. Aim for a perfect score. Let's get started.
Okay, first up, question 1. The name itself, Cryogenian, is a huge clue. It comes from ancient Greek, so any guesses what it literally translates to? And the answer is birth of ice. It comes from the Greek krios for ice and genesis for birth. I mean, you can't get a more perfect name for an era when the planet plunged into its most extreme cold spell ever. Question 2. When scientists are hunting for evidence of ancient ice ages, there's one very specific type of rock that's basically the smoking gun. It's the ultimate proof that a glacier was there. What is that rock called? That rock is called diamictite, and it's exactly what it sounds like, a messy jumble of rocks, mud, sand, all smashed together. It's the junk that a massive moving glacier scrapes up and spits out. Finding this stuff in places that used to be tropical is the key piece of evidence for the whole snowball Earth theory. Now, the Cryogenian wasn't just one continuous ice age. It actually had at least 2 of these massive deep freezes. So for question 3, what was the name of the very first one, the one that lasted the longest? It was called the Sturtian glaciation. And get this, it went on for 57 million years. To put that into perspective, the dinosaurs died out about 66 million years ago. So this single ice age lasted for almost that entire span of time. Just mind-boggling. All right, question 4. Let's talk about the sheer scale of this thing. The Snowball Earth hypothesis suggests the whole planet froze over. So, according to that idea, just how thick do you think the ice was that covered the oceans? 1,000 meters. That's a full kilometer, over half a mile thick. Can you even imagine that? A colossal sheet of ice covering the entire globe, turning our blue planet into one giant white cue ball. Now, an idea as wild as a completely frozen Earth really needed a catchy name to grab people's attention. So, question 5. Which Caltech scientist gave it the famous name Snowball Earth way back in 1992? That was Professor Joe Kirschvink. It was his paper and that incredibly memorable name that really took this idea from the fringes of geology and pushed it right into the mainstream debate. We are halfway through. Question 6. So, if the planet was a giant ice cube, how did it ever thaw out? Well, geologists found a major clue in a very weird rock layer sitting directly on top of all that glacial debris. What is this strange rock layer called? They're called cap carbonates. And this is where the story gets really wild. You've got evidence of a glacier, and then bam, right on top of it is a type of rock that usually forms in warm, tropical water. It's like finding a beach resort built on top of an Antarctic ice sheet. It's the strongest evidence we have that the climate didn't just warm up, it swung violently from a deep freeze to a super greenhouse. Of course, not everyone was sold on the idea of a completely frozen, hard snowball. A big scientific debate started. So, for question 7, what do we call the alternative hypothesis, the one that suggests Earth was more of a slush ball? That would be the slush ball Earth hypothesis. And the main difference, really, is that slush ball proponents think there was probably a belt of open ocean water around the equator. And that could explain how some early life, like algae that needed sunlight, managed to survive. It's a fantastic debate that's still going on. Okay, question 8. To really understand why this period is so important, we have to look at where it sits on the geologic timeline. The Cryogenian is a huge turning point, sandwiched between two other periods. Can you name the one that came before and the one that came after?
So it came after the Tonian period and just before the Ediacaran period. And this is so critical because the Ediacaran is when we see the first big explosion of large, complex animal life on Earth. The fact that this deep freeze happened right before that evolutionary leap, well, that's probably not a coincidence.
So, what could possibly trigger a global ice age like this? For question 9, scientists have a prime suspect, a gigantic volcanic region that erupted and whose weathering is thought to have sucked all the heat-trapping CO2 out of the atmosphere. What is this place called? The culprit is believed to be the Franklin Large Igneous Province, which is up in the Canadian Arctic. Thanks to some amazing high-precision dating, we know this massive volcanic event lines up perfectly with the start of the Sturton glaciation. Incredible geological detective work, right? All right, here we are, the last question. The Sturtian glaciation has been called a giant crusher. And even though it sounds totally destructive, it might have been exactly what the planet needed to prepare for the life that came next. So how did this crushing action help set the stage for evolution? Well, here's how it worked. Those massive ice sheets, a kilometer thick, ground entire mountain ranges down into a fine powder. Then, when the Great Thaw finally happened, all of that nutrient-rich dust washed into the oceans. It was like the biggest fertilizer dump in history, providing all the raw materials for surviving marine life to kickstart the next chapter of evolution. And that's all 10. So how did you do? Go ahead and tally up your score. If you got 8 to 10 correct, congratulations, you are a geological grandmaster. 5 to 7, you're a solid strata specialist. And if you got fewer than 5, hey, no problem, you're a curious prospector, which means you've got some amazing discoveries ahead. But honestly, knowing these facts is just the first step, because every one of these answers just opens up even deeper, more fascinating questions. I mean, how did anything survive under a kilometer of ice? What caused the Great Thaw? And how exactly did this cataclysm lead to the dawn of animals? Because in the end, learning about this ancient frozen world isn't just a geology lesson. It's a journey to explore our own roots. It's about the incredible resilience of life and the chain of chaotic events that ultimately led to us. If you want the full story, be sure to check out the complete source material. Thanks for playing along.